Hello friends, myself Rasmita Kumari Sahu. Today my topic is design of concrete structure. This is the introduction part. Reinforced concrete as a composite material has occupied a special place in the modern construction of different types of structure due to its several advantages. Italian architect Ponti once remarked that concrete liberated us from the rectangle. Due to its flexibility in form and superiority in performance, it has replaced to a large extent the earlier materials like stone, timber, and steel. Further, architects' scope and imagination have widened to a great extent due to its modulability and monolithicity. The design of this modern reinforced concrete structure may appear to be highly complex. However, most of these structures are the assembly of several basic structural elements such as beams, columns, slabs, walls, and foundations. Objectives of design of concrete structure. Every structure has got its form, function, and aesthetics. Normally, we consider that the architects will take care of them and the structural engineers will be solely responsible for the strength and safety of the structures. However, the roles of architects and structural engineers are very much interactive, and a unified approach of both will only result in an integrated structure where every material of the total structure takes part effectively for form, function, aesthetics, strength, as well as safety and durability. This is possible when architects have some basic understanding of structural design, and the structural engineers also have the basic knowledge of architectural requirements. When comes to methods of design of concrete structure, there are three methods of design of concrete structure. One is limit state method, another one is working stress method, and another one is methods based on experimental approach. The term limit state is of continental origin, where there are three limit states: serviceability, crack opening, and collapse. For reasons not very clear in English literature, limit state of collapse is termed as limit state. Working stress method. This method of design considered as the method of earlier times had several limitations. However, in situations where limit state methods cannot be conveniently applied, working stress method can be employed as an alternative. It is expected that in the near future, the working stress method will be completely replaced by limit state method. When it comes to methods based on experimental approach, designer may perform experimental investigations on models of full-size structures or elements and accordingly design the structure or elements. However, the four objectives of the structural design must be satisfied when designed by employing this approach. Moreover, the engineer in charge has to approve the experimental details and the analysis connected therewith. Then comes to characteristic load. The characteristic load is given clause number 36.2 of IS code 456/2000. is that load which has a 95% probability of not being exceeded during the life of the structure. Then comes to different types of loads. There are many types of loads like dead load, imposed load, wind load, snow load, combination of loads, etc. are there. Dead load. There are the self-weight of the structure to be designed. Needless to mention that the dimensions of the cross sections are to be assumed initially, which enable to estimate the dead loads from the known unit weight of the materials of the structure. The accuracy of the estimation thus depends on the assumed values of the initial dimensions of the cross section. The values of unit weight of the material are specified in Part 1 of IS 875. Imposed load. They are also known as live load and consist of all loads other than the dead loads of the structure. The values of the imposed loads depend on the functional requirements of the structure. Residential building will have comparatively lower values of the imposed loads than those of school of office buildings than wind loads. These loads depend on the velocity of the wind at the location of the structure, permeability of the structure, height of the structure, etc. They may be horizontal or inclined forces depending on the angle of inclination of the roof for pitched roof structures. They can even be suction type of forces depending on the angle of inclination of the roof or geometry of the buildings. Then comes to snow load. There are important loads for structures located in areas having snowfall, which gets accumulated in different parts of the structure depending on the projections, heights, slopes, etc. of the structures. Combination of loads. There are many combinations are done like dead load and live load, etc. are there. Design of structures would have become highly expensive in order to maintain their serviceability and safety if all types of forces would have acted on all structures at all times. Accordingly, the concept of characteristic loads has been accepted to ensure that in at least 95% of the cases, the characteristic loads considered will be higher than the actual loads on the structure. However, the characteristic loads are to be calculated on the basis of average or mean load of some logical combinations of all the loads mentioned in this. These logical combinations are based on the natural phenomenon like wind and earthquake do not occur simultaneously. Live loads on roofs should not be present when wind loads are considered. Thank you for watching.